So now we will discuss about variation of ionization enthalpy in the periodic table. We know that ionization enthalpy is nothing but amount of energy which is required to remove the outermost electron from a neutral isolated gaseous atom. Whether it will remains the same for down the group as well as across the period. So ionization enthalpy ಎಲ್ಲ elements ಗೂ same ಇರುತ್ತಾ change ಆಗ್ತಾ ಹೋಗುತ್ತಾ, so that we will discuss now. The first one, that is down the group. What happens to the ionization enthalpy down the group? We all know that as we move down the group, what happens to the atomic size? The atomic size will gradually increases. That is, for example, lithium ಅಂತ ಕನ್ಸಿಡರ್ ಮಾಡ್ರಿ. It is 1s2, 2s1 outermost shell ಮಾತ್ರ ಬರೀತಿದ್ದೀನಿ. Next one, lithium, next sodium, that is 3s1. Next potassium, that is 4s1. Okay, now so as we move down the group, what happens to the atomic size? The atomic size will gradually increases. So atomic size increase ಆಯಿತು ಅಂದ ತಕ್ಷಣ what happens to the effective nuclear charge, that is force of attraction between the nucleus and outermost electron will gradually decreases. Because distance ಜಾಸ್ತಿ ಆಗ್ತಾ ಹೋಯಿತು ಅಂದ ತಕ್ಷಣ ನ್ಯೂಕ್ಲಿಯಸ್ಗೆ ಎಲೆಕ್ಟ್ರಾನ್ಸನ್ನು ಹಿಡ್ಕೊಳ್ಳೋ ಪವರ್ ಏನಾಗ್ತಾ ಹೋಗುತ್ತೆ, ಕಡಿಮೆ ಆಗ್ತಾ ಹೋಗುತ್ತೆ. That means the outermost electron can be removed very easily. So therefore we can say that what happens to the ionization enthalpy? The ionization enthalpy will gradually decreases as we move down the group. Okay, now one more concept, that is we all know about the shielding effect. So if the inner electrons are more, so then the outer electrons can be removed very easily. So here, as we all know that, so lithium, sodium, potassium, rubidium hang move ಆಗ್ತಾ ಹೋದ ತಕ್ಷಣ what happens to the atomic number? The atomic number increases. Atomic number is nothing but the nuclear charge. So nuclear charge ಜಾಸ್ತಿ ಆಗ್ತಿದೆ, but ಇಲ್ಲಿ inner electrons ಏನಾಗ್ತಿದೆ, ಜಾಸ್ತಿ ಇದೆ. Right? Inner electrons ಜಾಸ್ತಿ ಆಯಿತು ಅಂದ ತಕ್ಷಣ what about the shielding effect? The shielding effect is more. So if the shielding effect is more, the increased shielding effect outweighs the increased nuclear charge. So even though nuclear charge increase ಆಗ್ತಿದ್ರು ಕೂಡ shielding effect is more. We know that whenever the shielding effect is more, the outermost electrons can be removed easily. So for that reason, so it requires very less amount of energy to remove the outermost electron. Or in a simple word, we can say that electrons can be removed very easily. That means for that reason we can say that ionization enthalpy decreases down the group. This is very simple concept, so and this is also very important for your examination purpose. Inant baritiri, as we move down the group, what happens to the atomic size? Atomic size increases. And what happens to the effective nuclear charge? Effective nuclear charge will gradually decreases. So therefore ionization enthalpy will gradually decreases as we move down the group. Or you can also write this one, the increased shielding effect outweighs the increased nuclear charge, and the removal of the outermost electron, it requires less energy. So this also you can write. Now variation of ionization enthalpy along a period. So down the group ಏನಾಗುತ್ತೆ ಗೊತ್ತಾಯಿತು, so ionization enthalpy decreases. Now we will see what happens to the ionization enthalpy along a period. So we know that on moving along a period, that is from left to right or across a period, both are one and the same. On moving along a period, that is from left to right, we know that atomic size decreases. Why the atomic size decreases? This is because the added electrons will enter into the same shell, right? So added electrons same shell ಗೆ enter ಆಯಿತು ಅಂದ ತಕ್ಷಣ ಏನಾಗುತ್ತೆ, what happens to the effective nuclear charge? The effective nuclear charge will increases. That means the force of attraction between the nucleus and the outermost electron is more. At that time, whether it is easy to remove the outermost electron? No. So that means we require more amount of energy to remove the outermost electron. Therefore we can say that ionization enthalpy is more. Got it? So on moving along a period or moving across a period, that is from left to right, so atomic size will gradually decreases. This is because the added electrons will enter into the same shell. At that times what happens to the effective nuclear charge? That is ಹೀಗೆ ಅಟಾಮಿಕ್ ಸೈಜ್ ಏನಾಗ್ತಾ ಹೋಗುತ್ತೆ, ಡಿಕ್ರೀಸ್ ಆಗ್ತಾ ಹೋಗುತ್ತೆ. The force of attraction between the nucleus and the outermost electron is more. At that time it is not that much easy to remove the outermost electron. So therefore more, we require more amount of energy, and that energy is nothing but the ionization enthalpy. Or in one more term, if we explain this, so we all know that as we move across the period, what happens to the atomic number? Atomic number increases, which is nothing but the nuclear charge increases. But the added electrons will enter into the same shell. So when the added electrons will enter into the same shell, whether the shielding effect increases? No, at that time. So when the added electrons enter into same shell, the shielding effect remains same, right? The shielding effect remains same, correct alva? The shielding effect remains enirutte, so it will remains same. So at that time what happens? Here the increased nuclear charge is more than that of the shielding effect. Here the increased nuclear charge outweighs the shielding effect. So nuclear charge ಜಾಸ್ತಿ ಇದೆ when compared to that of the shielding effect. For that reason the outermost electrons are more firmly held. So ಗಟ್ಟಿಯಾಗಿ ಹಿಡ್ಕೊಂಡಿರುತ್ತೆ, and hence ionization enthalpy increases along the period. Got it? And it is very difficult to remove the outermost electron. Once again, as we move along the period, atomic size decreases, effective nuclear charge increases. And one more thing, here the increased nuclear charge overweighs the shielding effect. As a result, outermost electrons are more firmly held, and hence the ionization enthalpy will increases along a period. So ಅಲ್ಲಿ ಏನು ಹೇಳಿದ್ರಿ, down the group ಅಲ್ಲಿ ಹೇಗೆ define ಮಾಡಿದ್ರಿ? So in the down the group what you have explained here, there you have explained the increased shielding effect outweighs the increased nuclear charge. So ಅಲ್ಲಿ shielding effect more when compared to that of the nuclear charge. So here reverse, right? So this is the way that you have to remember the variation of ionization enthalpy in the periodic table. So they will ask this for the 3 marks, okay? Now we will see the graph, that is ionization enthalpy versus atomic number, right? Ionization enthalpy, it is expressed in the terms of kilojoules per mole, atomic number in terms of Z. So this is down the group, that is lithium, sodium, potassium, rubidium, cesium. We know that as we move down the group, what happens to the ionization enthalpy? The ionization enthalpy will gradually decreases. That means easily we can remove the outermost electron. So this is in the case of as we move down the group. So at the same time, what happens to the ionization enthalpy if we move across the period or if we move along the period? You can see some changes here. You can see some fluctuations, that is in the case of beryllium and boron, and in the case of nitrogen and oxygen. So ನಮ್ಮ statement ಪ್ರಕಾರ ಏನಾಗಬೇಕಿತ್ತು, as we move across the period or along the period, that is from left to right, ionization enthalpy increase ಆಗಬೇಕಿತ್ತು, right? But ಇಲ್ಲಿ ನೋಡಿ, so you can see the changes here. Beryllium ಕಿನ ಬೋರಾನಿಗೆ ಕಡಿಮೆ ಇದೆ. So ಅದೇ nitrogen ಮತ್ತು oxygen compare ಮಾಡಿದ್ರೆ oxygen is less. So why is this? So that we will discuss now. That is, first one, in the case of beryllium and in the case of boron. So see here, beryllium, whose atomic number is 4. So if I write down the electronic configuration, it is 1s2, 2s2. Right? Whereas in the case of boron, its atomic number is 5 and its electronic configuration is 1s2, 2s2, 2p1. So here we can say that the penetration power of S electron is more. As I told that penetration power kuda discuss madidvi, that is nothing but the firmly hold or it firmly hold the electrons, right? So S electrons, the penetration power is more. This we have discussed. For penetration power is more than that of the P, D, than that of D and F. So this is because S subshell is spherical and density of the electrons around the nucleus is more. So ee concept na discuss madidvi, right? So here we can say that penetration power of this electron is more. So for that reason, so here as I told that the ionization enthalpy of beryllium is more than that of the boron. Or one more point we can say that, so il nodi, so if I consider, so this is the nucleus, here n is equals to 1, this is n is equals to 2, so this dotted lines, this is 2p ಅಂತ consider ಮಾಡ್ರಿ. Okay, the inner electrons are more. So whenever the inner electrons are more, we can say that shielding effect is more. Whenever the shielding effect is more, the outer electrons can be removed very easily. So therefore, we can say that the ionization enthalpy of beryllium is more than that of the boron. So what we can say here, we can say that that is, in the case of boron, in boron 2p electrons are more shielded. 2p electrons are more shielded to the, so 2p electrons are more shielded from the nucleus, from the nucleus by the inner core electrons, So this is the reason. In the boron, so what we can say, in the boron 2p electrons are more shielded from the nucleus by the inner core electrons when compared to that of the s electrons. For that reason, we can say that the ionization enthalpy of boron is less when compared to that of the beryllium. Okay, so this is the reason. So beryllium helbekadre enant heltivi, here penetration power is more ant helbit heltivi. Boron ige explanation kodbekadre what we are going to explain here, in boron 2p electrons are more shielded because inner electrons ಜಾಸ್ತಿ ಇದೆ, ಅದನ್ನೇ ಹೇಳ್ತಿರೋದು, more shielded from the nucleus by the inner electrons. The outer electrons can be removed easily. For that reason, we can say that the ionization enthalpy of boron is less than that of the beryllium. So this is the one point. So at the same time, if we consider the nitrogen and oxygen, so why the ionization enthalpy of nitrogen is more than that of the oxygen? So this I have already explained. So in the nitrogen, that is, it is half filled. The atomic number of nitrogen is 7. So if we write down the electronic configuration, it is 1s2, 2s2, 2p3. So p subshell is half filled, and we know that whenever the subshells are half filled and completely filled, they will attain the stability. Once the atom will attain the stability, we require more and more amount of energy to remove the outermost electron. For that reason, the ionization enthalpy of nitrogen is more when compared to that of the oxygen. So if they ask the question like this, why the ionization enthalpy of oxygen is less than that of nitrogen? So ionization enthalpy of oxygen is less than that of nitrogen and kelidre, how we have to answer? So that I am going to show now. So we know that oxygen atomic number is 8, and if I write down the electronic configuration, it is 1s2, 2s2, 2p4. Right, now I will concentrate on the p subshell. So p subshell consists of 3 orbitals, that is, which are those 3 orbitals? That is px, py and pz. So how many electrons are there? 4 electrons are there. So whether we are going to fill the electrons like this, 4 electrons fill aitu ant heltira? No. According to which rule we have to fill the electrons? According to Hund's rule, we are going to fill the electrons. That is, first each and every orbital consists of single electron. After that, pairing of electron will take place. That is 1, 2, 3, after 4. So whenever the added electrons will enter into the fourth electron will enter into the px orbital, so what happens? Electrons naduve enagutte, the repulsion will takes place. We know that electrons are negatively charged, right? The electrons are negatively charged. Negative charge hatra band takshana enagutte, they will repel each other. So repulsion adaga, the fourth electron can be removed very easily. For that reason, we can say that the ionization enthalpy of oxygen is less than that of the nitrogen, right? So what is the reason for this? So here the fourth electron will enter into the p subshell, where according to the Hund's rule, the px orbital, where the electron repulsion will takes place, and the fourth electron can be removed easily. For that reason, the ionization enthalpy of oxygen is less when compared to that of the nitrogen. So idina give reason question ige, so they may ask for the 1 marks or the 2 marks. We'll solve one problem, that is the first ionization enthalpy values of third period elements, so that is sodium, magnesium, silicon are 496, 737, 786 kilojoules per mole. Predict whether the delta H values for aluminium will be more closer to 575 or 760 kilojoules per mole. ಏನು ಕೇಳಿದಾರೆ ಅವರು? ಸೊ ಅಲ್ಯೂಮಿನಿಯಂ ವ್ಯಾಲ್ಯೂ, ಅಯನೈಸೇಷನ್ ಎಂಥಾಲ್ಪಿ ವ್ಯಾಲ್ಯೂ ಯಾವುದು ಕ್ಲೋಸ್ ಆಗಿರುತ್ತೆ? 575 kilojoules per mole or 760 kilojoules per mole. So I am going to write down the third elements, that is, so third period elements ಅಂದರೆ ಯಾವ್ದು ಬರುತ್ತೆ? Sodium, that is magnesium, next one is aluminium and silicon. So what is the atomic number of sodium? It is 11, magnesium 12, aluminium 13, silicon 14. So if I write the valence electronic configuration, so what is the valence electronic configuration of sodium? It is 3s1. For magnesium it is 3s2. For aluminium it is 3s2, 3p1, and for silicon it is 3s2, 3p2. Correct? For silicon it is 3s2, 3p2. So the value of aluminium, the ionization enthalpy value of aluminium should be lower than that of the magnesium. So ಏನಂತ ಹೇಳಿದಾರೆ ಅವರು? We have to predict the value of the ionization enthalpy of the aluminium. So see here in this case the penetration power is more in the case of magnesium because yes subshell ಇದೆ. But in the case of aluminium ಏನಾಗುತ್ತೆ? The effective shielding of 3p electrons from the nucleus by the 3s electrons. Here the shielding effect is more. The outer electrons can be removed very easily. So therefore we can say that the ionization enthalpy of aluminium is less than that of magnesium. Gotaita? So here we can say that here the penetration power is more. We know that for the S subshell it is more. So the nucleus is strongly held the electrons. Illenagatte outermost shell, the inner shell ಜಾಸ್ತಿ ಆಗ್ತಾ ಹೋಯಿತು ಅಂದ ತಕ್ಷಣ outer electrons can be removed easily. For that reason we can say that the ionization enthalpy of aluminium is less than that of magnesium. Magnesium value ಎಷ್ಟು ಅಂತ ಹೇಳಿದಾರೆ ಅವರು? 737. ಅದ್ರ ಕೆಳಗಡೆ ಇರಬೇಕು ಅಂದರೆ ಏನಿರಬೇಕು? It should be more closer to 575 kilojoules per mole. So therefore we can say that the ionization enthalpy of aluminium is more closer to 500 and so it is more closer to, so what is that? Is 575 kilojoules per mole. Yes.